Okay, the structure of an atom notes. Okay, atoms have three subatomic particles. There's protons, neutrons, and electrons. Now, protons we write with a little p with a little plus sign above it. Neutrons we write with an n with a 0 above it. And electrons with a little minus above it. That indicates the charge. In other words, protons, which is the particle, has a relative mass of 1 AMU, and they have a positive charge, and they're located inside the nucleus. Neutrons have a relative mass of 1 AMU. They have no charge, and they're also found inside the nucleus. Now, electrons are much, much, much smaller. They have a relative mass of 1 over 1836. In other words, they're about 2,000th of an AMU, of the size of a proton or a neutron. So they're kind of really super teensy tiny. They really don't even add any kind of mass to the atom. All of the mass is located in the nucleus. They are found outside the nucleus in energy levels. And I can't even spell today. In energy. That's a lot. Oh, okay, I give up. See if I can learn to spell energy levels. Energy levels. There we go. Okay. Now, AMU stands for atomic mass unit. Okay, now the number of protons is the atomic number. So, like, if you look at on the periodic table, hydrogen has an atomic number of 1. That means it has 1 proton. Helium has an atomic number of 2. That means it has 2 protons. Now, since atoms are neutral, the number of protons equals the number of electrons. So since hydrogen has 1 proton, it has 1 electron. Helium has 2 protons and 2 electrons. Everything's got to equal itself out. Now, the mass number of an atom is the number of protons plus the number of neutrons. Oops. Okay? So if you have one, like hydrogen has a mass number of 1, which means it has 1 proton and no neutrons. Helium has 2 protons and 2 neutrons, so its mass number is 4. Okay? So you just have to add the protons and the neutrons to get the mass number. Now, if you're trying to find the mass number on the periodic table, all you do is you round the atomic mass, which is a decimal number, to the nearest whole number. Now, you got to use this to find the number of neutrons in the major isotope. Okay, so the number of neutrons is the mass number minus the atomic number. So if we look at carbon, carbon has a mass number of 6, an atomic number of 6, and a mass number of 12. It's 12.0 something, so the mass number is 12. So we look at it, atomic number means the number of protons, so there's 6 protons and 6 electrons. And then we take 12 minus 6 to give you 6 neutrons. Okay? And sulfur, same thing. Atomic number of 16, so it's got 16 protons, 16 electrons. It has a mass number of 32, so when you subtract them, that means you get 16 for the number of neutrons. Now, probably about maybe the first 20 elements, or at least the first 18, the number of neutrons and the number of protons is the same. After that, they're not even close. They might be 1 or 2 off. Sometimes they're 4 or 5 off from the number of protons. So, I mean, lead has a atomic mass of 207, and it's only got 60 some odd protons. So, you know, if it had the same number, it would have a mass number of 120 something, and it's not, it's 207. So the heavier atoms have a lot more neutrons than they do protons. Okay, not all atoms of a particular element have the same number of neutrons. Now they're going to have the same number of protons, okay, because they all have the same atomic number. So all atoms of carbon have 6 protons, no matter what. All atoms of sulfur have 16 protons, no matter what. It's the neutrons that can vary. Okay, so let's look at this. There are 3 main isotopes of carbon. Okay, we've got carbon 12, carbon 13, and carbon 14. And the numbers that I've circled in red are the mass number. So in order to find the number of neutrons, you would take, like for carbon 12, it's 12 minus 6, which equals 6. Carbon 13, mass number of 13 minus 6, and you get 7 neutrons. And then carbon 14 has a mass number of 14, and when you subtract the 6, you get 8 neutrons. Now there is another way, there's another way of indicating the isotopes. There's another way of writing it. And we write it like this with the, let me move it this way. Like this would be carbon 12, carbon 13, and carbon 14. Sometimes it's written the other way. So just remember, if you see two numbers, then the smaller number is the number of protons. But if you see one number, that's the mass number. We never just write the atomic number. That you can look up in the periodic table. So this is always the mass number if it's just one number written. If there's two numbers written, the smaller one is the atomic number. Okay? Okay, so let's look at, now on the periodic table, you'll see something that looks in a block, of course. And what that block is, it has a few things in it. So you'll always see the symbol. So this is the elements, whoops, I guess I should hit the pen. This is the elements symbol right here. The atomic number is at the top. And then this is actually the average atomic mass. So I should put average atomic mass here. Okay? It's not the mass number. It's the average of all of the isotopes. Now when you round it to the nearest whole number, you're actually rounding it to the mass number of the major isotope, the one that's in the most abundance. And really, that's all you have to know. Okay, so the mass number here would be 24, which means the major isotope has 12 neutrons. 24 minus 12 is 12. Okay, well that's all for tonight's notes, today's notes. So, well, bye.